Right, so it's a few months since we last looked at this monitor. It's frankly been a bit too cold to come out into the shed and work on things. So I thought it about time that we pick up and do another session on the monitor. If you remember last time we had problems with the EHT supply again, which does seem to be a general weakness on these monitors. In fact, two of the power supplies failed. One turned out to be a fairly simple fix. There was a lot of arcing from inside one of the valve bases. That turned out to be simply that the output lead had come unsoldered and was just arcing. The leads are very short, the solder joints are very old, and mechanical flexing of various parts of the power supply just led it to come adrift. So that was a fairly easy fix. The other supply failed. It was one of the germanium power transistors had failed. Now there are no more of those left, so the only alternative there was to try a pair of silicon transistors in place. Bit of a sort of a suck it and see outcome really, because of the bias voltages are different on silicon transistors. Sometimes they'll work as a direct substitute without any other modification, sometimes they won't. In this case we got lucky. The power supply seems to work fine with silicon transistors in place. They're going to be more reliable, and we simply can't get any more germanium power transistors easily. So with that out of the way, we proceed to find the next problem on the monitor. So if I turn the monitor on, it's just to simply save me reaching around the front of the monitor, I'm just switching it on at the main socket. And straight away the overload cutout has operated. Now the circuit board on the right hand side of the monitor is the horizontal scan board and the power supply. And rather handily, the power supply, the minus 11 volt power supply, has individual output pins that connect to the various functions of the monitor. So for example, we have the video sync and tube base supplies, the vertical scan board, the horizontal scan board, so it loops back onto itself effectively, and the HT box. So we can disconnect each of those in turn to relieve the load on the power supply, and hopefully we'll then find which area of circuitry is drawing excessive current and operating the overload cutout. I'd already powered the monitor up without having the HT connected, because that's been the bane of my life frankly so far, so I thought I'd try the monitor without that to see if there are any other faults. And lo and behold, yes we have. So let's proceed to disconnect them one at a time to try and find out what the problem is. And you probably guessed, it's the horizontal scan board that's the problem. With this wire disconnected, the power supply is not shutting down. Horizontal scans on CRT monitors, frequent source of failure, fairly highly stressed bit of circuitry. So I think what we'll do is we'll have a quick look at the circuit diagram, which shows that there are just 6 transistors involved, and my money is on the final stages. They're the ones that are most highly stressed. They're the ones that are going to short across the power supply if there's a fault on those transistors. The output stage is transformer coupled, so even if there's a fault on the earlier stages of the horizontal scan, it's unlikely to cause a problem later on. So I think we'll look at the output transistors first. Let's have a look at TR304, that's the horizontal output transistor. And that's still a transistor, so we'll start looking elsewhere. Well, now that I know it's not the final stages of the horizontal oscillator board, much to my surprise, I thought I'd just connect up the external supply and see if that'll help me decide which is the actual faulty part. And if I turn it on, it's overcurrented straight away. There's no way that this should be taking 2 amps or more. Since we know that the latter stages of the horizontal oscillator are probably okay, I'm actually beginning to wonder whether it's one of the decoupling capacitors across the supply that have failed short circuit. Because if it's any of the early stage transistors that have gone short, the series resistances around them will prevent excessive current anyway. So there simply isn't the opportunity to pass such a high current through any faulty transistors. So let's have a look at the electrolytics next. Well, my hunch proved wrong, and the electrolytics were all fine. I noticed that there was still an overload until TR305 was removed. That in turn was okay, so attention then turned to this nasty little component tacked on the back of the circuit board, which is D310, which is across TR304. So if we measure that, lo and behold, short circuit, and that's the cause of our trouble. So I've borrowed from one of the scrap boards a similar component, so we'll get that in place and see if that's fixed the problem. Right, well, changing that component seems to have given us a working monitor again. There's still some issues with it. First of all, there's the occasional flashover from the EHT. I've got to investigate that a bit further to see if it's the EHT box itself or the fact that I've had to stick rather a lot of aluminium foil around the back of the tube because the DAG material has started to fall off the back of the tube in several areas, especially where the EHT box makes contact via some sprung metal tags to the back of the tube. So it might be that my bit of aluminium foil isn't making very good contact, or it might yet be issues with the EHT supply. The other thing is that suggests it is the supply that's still giving problems is if I turn the contrast up a bit too high, the picture starts to balloon, which suggests that the HT regulation is not very good. So that needs looking at. Also, the vertical scan is offset somewhat. I'm not too sure why that is at the moment. It's possibly some problem with the vertical scan circuit that still needs looking at. But I'm going to turn it off for now and call it a day because I don't think I want to face repairing yet another power supply. So here's the main transformer, and here this wire should not be in close proximity like it is on this one to the windings of the transformer, because that wire is actually at earth potential. So what was happening was every now and again a spark was jumping between the supposedly insulated part of the transformer through the insulation on the wire to ground, and simply just moving that piece of wire out the way fixed the problem. So a similar trick needs to be done on this one. The wire is actually rather springy and keeps wanting to spring back and touch the transformer. So another little gotcha there. The compression at the lower half of the picture and the slight offset turned out to be the field output transistor that wasn't doing its job properly. That was TR204, the vertical output stage power transistor. Although it measured okay on the transistor tester, exchanging the component has fixed the problem, and I think that's possibly because the transistor tester is not that good at accurately measuring the performance of a power transistor. So that's fixed that problem, and I've fine-tuned the resistor that sets the contrast control in the drive to the resistor that we changed a couple of episodes ago, so that the control is now operating more sensibly. Right, I was beginning to think that this monitor was never going to have its side covers ever put back on again. Final somewhat cosmetic issue is the input select knob. The switch itself is very stiff, as it is on the other monitor, and that actually resulted in the original knob splitting. sheerly under the effect of the amount of force required to turn the knob, and the fact that the plastic's obviously 50 years old. I have repaired it, but I haven't got any confidence in the strength of this knob any longer. So I've been exercising this knob a lot, and it has freed up a bit. But nonetheless, I think I'm going to exchange one of the good knobs into this position, and put the weakened, repaired one in one of the other controls, which are obviously very easy to move.